Hello, friends. We often think of Earth's climate as a self contained system influenced by the solar radiation, atmospheric gases, and ocean currents. But what if I told you that our planet's long term climate history might also be subtly steered by the gravitational nudges of distant stars? Cosmic neighbors we really consider important, right? It sounds like science fiction, but a growing body of research suggests that a close encounter with passing stars over millions of years could have played a significant role in shaping Earth's temperature, ice ages, and even the condition for life as we know it. Our sun, seemingly solitary in its dominion over solar system, it is actually just one of billions of stars swirling within the vast spiral of the Milky Way galaxy. Our solar system is constantly orbiting the galactical center, and it does so. It occasionally encounters other stars passing by in our cosmic neighborhood. While direct collisions with other stars is incredibly rare, even relatively close flyby occurring within a few light years can exert a subtle but significant gravitational influence on our outer reaches of our solar system, particularly a region known as the Oort Cloud. The Oort Cloud is, theoretical spherical cloud of icy small objects, the remnants from the formation of our solar system, believed to be extended far beyond the orbit of even the most distant planet. It thought to be the source of many long period comets. These celestial wanderers that take thousands of even millions of years to complete a single orbit around the sun. When the star passes through relatively close to our solar system, its gravitational pull can act like a cosmic agitator on the Oort cloud. This gentle nudge can disrupt the orbits of countless icy bodies, sending a cascade of comets hurtling towards the inner solar system. We call this event Comet Showers. Now, the vast majority of these comets will never come close to Earth. They might plunge toward the sun, disintegrate, or they might be deflected by the gravity of the giant planets like Jupiter and Saturn. However, a statistical increase in the number of comets traveling the inner solar system inevitably raises the probability of the collision with Earth. Imagine a cosmic pinball machine where a passing star acts as the flipper, sending a stream of icy ball towards the inner solar system, which is like inner targets. Earth in its orbit around the sun becomes one of the potential targets. What happens when a comet large enough to survive its fiery plunge through Earth's atmosphere actually impact our planet? The consequence can be dramatic and far-reaching, with significant implications for the Earth's climate. A large impact even would eject enormous amount of dust, ash, vaporized rock into the atmosphere. This debris cloud can block sunlight, leading to a period of global cooling, often referred to as the impact winter. The darkness and the reduced temperature can severely disrupt the photosynthesis, impact plant life, and the entire food chain. Furthermore, the impact can trigger massive wildfires, releasing vast quantity of greenhouse gases like carbon dioxide with atmosphere over long time scale. This influx of greenhouse gas can contribute to global warming. The composition of the impacting comet itself plays a role. Icy comet carries significant amount of water, and a large impact could introduce substantial amount of water vapor into the upper atmosphere, potentially affecting cloud formation and precipitation pattern. The Dinosaurus killer impactor, believed to have contributed to the extinction of the dinosaurs, serves as a stark reminder of the catastrophic potential of the large celestial impact. While the smaller comet impacts are more frequent, even these can have localized or regional climate effect. So, how do scientists have even begun to investigate such subtle and infrequent cosmic influences on Earth's ancient climate? The evidence is often indirect. pieced together from the geological and astronomical observations. The geologists look for specific layers in the Earth's crust that contain unusual concentration of elements like iridium, which is much more abundant in asteroids and comets than in the Earth's crust. The presence of such impact layer can signal past collisions. Paleontologists study the fossil records looking for patterns of mass extension or sudden shift in biodiversity that might correlate with potential impact events or periods of increased comet activities. Astronomers, on the other hand, study the orbits of stars in our galactical neighborhood, trying to identify stars that might have passed close enough to our solar system in the distant past to perturb the Oort Cloud. Computer simulation help them model these stellar encounter and estimate the likelihood of resulting comet shower. One intriguing piece of evidence involves the analysis of the ancient ice cores from Antarctica and Greenland. Scientists look for specific isotopes such as helium-3, which can be more abundant in interplanetary dust and potentially increase during the period of increased comet flux, which is important fact. While definitely proving a direct causal link between specific stellar flyby and a particularly climate change event billions of years ago is incredibly challenging. The accumulating evidence suggests that these cosmic interaction might be subtle but persistent driver for long-term climate variability on Earth. It is important to remember that our solar system is not static. It's a constant moving. It's constantly moving through the dynamic environment of the Milky Way galaxy. Over vast timescales, it will inevitably encounter other stars passing by at varying distances. Understanding the frequency of the potential impact of these stellar flybys is crucial for comprehending the long-term evolution of our solar system and potentially hazardous event for Earth. While life extinguishes impact from large comet triggered by stellar flyby is rare event, the cumulative effect of smaller impact and increased comet dust in our atmosphere over millions of years could contribute to gradual climate shifts. Furthermore, the studying the dynamics of Oort cloud and the potential for stellar disturbance help us understand the overall population and behavior of the comet in our solar system, providing valuable insight into early history of our planetary system. From the faint gravitational tug of distant star to the dramatic impact of comet on our planet, the idea that passing stars could have subtle impact and also subtly steered Earth climate over past stretch of time is powerful reminder of our interconnectedness with the cosmos. While we often focus on terrestrial factors influencing our climate, this research opens up fascinating new perspective on long-term drivers of Earth's environmental history. So thank you for joining me today on this cosmic exploration of cosmic and also cosmic neighbors and understanding how passing stars may have changed Earth's climate. We hope this discussion has broadened your understanding of our planet's dynamic relationship with galaxies around us. Until next time, keep looking up and remember the story of Earth climate is written not just in rock and ice but also in the movement of distant stars. So thank you friends, and I will catch you again in the next one.